Algebra 1, Lesson 118, page 496. In the past, what we've done is we have factored things like this by putting them in two sets of parentheses. So if we had x squared plus 4x plus 4 like this equals 0, we would take and factor this thing, x plus 2, x plus 2, and we'd set this equal to 0, set this equal to 0, and we'd have x is equal to minus 2, x is equal to minus 2. Now that's great. There are many times, maybe even most of the time, when it doesn't work. When there is nothing times itself that added together equals this without using fractions, decimals, other things. So there's another way that we could always solve. Actually, there's two more methods. This lesson and the next lesson. There's two ways you can solve any quadratic, no matter what numbers are with it. Doesn't matter, big number, little number, doesn't matter. We can always solve it. So we've got 2x plus 3 equals negative 5. I put it like this. This will not factor into parentheses. The only choices I have here are 1 and 3. And if I add those together, I'm going to get 4. I will not get that. But there is a way to factor it, okay? And here's what we're going to do. This is called completing the square. You're going to do this one time, and then next year we'll find it again, and we'll use a lot. You'll be very familiar with it, but I want you to just think about it. This is another way to do it. It's not hard to do. This is the process. So we start, it has to be in descending order equal to 0. First step is to take the 3 to the other side. First step is take the 3 to the other side. I should have shown that. We have x squared plus 5x, and we leave a hole there, minus 3, like that. We take the constant to the other side. If it's plus here, it's minus over there. If it's minus here, it's plus over there. All right? And we leave a hole open. Okay? Now what you do next is you take the constant off of the x term. That's a 5. And in this, it doesn't matter if it's positive or negative. You just take this number here. You always, every time, you put it over 2. If it's reducible, you reduce it. If it's not reducible, you just leave it. Either way, you put it over 2 and you square it. 25 over 4. All right? So no matter what you've got, you take the coefficient of the x term, you put it over 2, reduce it or not, and square it. It's 25 over 4. 25, 5 squared is 25, 2 squared is 4. Then, where we have that hole right here, we're going to add that thing in. We always add it. It's never minus, because when we square it, even if that was a negative 5, it's still going to come out positive. Okay? Get me on this. If this is a negative here, doesn't matter. You're still going to add it in here, because when we square it, we always lose that negative. Okay? So you add it in this hole here. If I add it to this side, I've got to add it to the other side. Y'all got that? Now this is called completing the square. What that means is this is now a perfect square. If I were to factor this right here into the parentheses, both of them would be the same. Here's what we're going to do. This is now completing the square. This is a perfect square. The square root of x squared is x. The square root of 25 over 4 is that right there, what we started with. Middle term will drop out because, won't drop out. They're both the same. It's this times this. If I multiply it out, I get this. This is a perfect square. That's the purpose of doing this. So you take the square root of the first term, the square root of this term, and whatever sign that is goes here. If that was a minus, this is going to be a minus. Super easy. And you have to do this math over here. Minus 3 plus 25 fourths is 13 over fourths. And listen to me, it's got to be improper. You cannot use a mixed number over here. It has got to be improper. All right? So now, since this is squared, I want to get rid of that square. We do that by taking the square root of both sides. Take the square root of this, take the square root of the top, square root of the bottom separately. and it's going to be plus minus. Critical, very important. Okay? When I take the square root of a square, it just drops the square off, drops the radical off. They cancel each other out. So this is right over here. This is the square root of 13. I don't know what it is. Square root of 4 is 2. Something to look for is these numbers will always be the same. Okay? So last step is I want to get x by itself. Plus, so I subtract 5 over 2 from this side. So I just said 5 plus or minus this over the common number 2. Okay? And it's minus. So this right here is the answer. It's minus 5. I guess I could do this. Minus 5 plus or minus radical 13 over 2. If I was to run this out and get answers, I would have minus 5 plus radical 13 and divide that by 2. I want to have minus 5 minus radical 13 and divide that by 2. I could make this a decimal. I could get 2 decimal approximation answers. Okay? Okay, I'm going to do another one of these just because they're so much fun. All you have to do is remember the steps. Okay, this is one of those things where you've got to get the steps down. The best place to look for the steps is on example 118.3 because they have them fairly simplified steps there. Okay, so we've got x squared plus 1. So x squared plus 1 equals 3x. We're going to put it in descending order. X squared. Subtract this over here. Minus 3x. Plus 1 equals 0. Took everything off that side. I'm going to take this to the other side. X minus 3x equals negative 1. Leave a hole there. Take this number, the coefficient. I don't care if it's negative or not. Does not matter. I'm going to take this number and put it over 2. 3 over 2. I can't reduce it, so I'm going to square it. 9 over 4. Okay? I'm going to take this 9 over 4. It is now positive. All right, we took a negative here. This negative 3 times negative 3 is 9. Doesn't matter. That's why it doesn't matter if this is negative or positive. You're always going to add this. You add 9/4. To keep it balanced, if I add over here, I have to add 9/4. All right? So next thing, this now is a perfect square. Do you understand that? This is a perfect square. It will factor like this. I lost my square. I apologize. The square root of x is x. That's a minus. That's a minus. The square root of 9 over 4 is 3 over 2. If you're not sure what that is, you always come back to right there. That is what the square root will be. We need both of these numbers because this is what we added over here. Equals, this is where you get out your handy dandy little calculator. And I don't even try to work these longhand anymore. So I have 9 over 4 minus 1 equals, second function fraction, 5 over 4. This equals 5 over 4. All right? That's squared. I'm sorry. I'm losing everything. So we're going to take the square root of both sides to get rid of that. We're going to take the square root of this, square root of this. Square root of this is x minus 3 over 2 equals. Since we took the square root, it's plus minus. I don't know what the square root of 5 is, but I do know what the square root of 4 is. That's a 2, that's a 2. Last step is I'm going to add this to the other side. Okay, so we have x equals. This is plus now. 3, if you want to do it this way, you can. 3 halves plus or minus square root of 5 over 2. I like to do it like this. X equals 3 plus or minus radical 5 over 2. That's the answers. There's 2 of them. You got to remember, when you square root both sides, you pick up that plus minus. All right? So first of all, descending order. Second, take the constant to the other side. Okay, right there. Leave a hole. Take the coefficient of x. Not here, that. And not the x, just the number. Put it over 2. If it reduces, do it. If it doesn't matter. Square it. 9 over 4 for this one. Add it to both sides. It will always be plus, because plus or minus, put it in here, it's coming out positive because we square it. Add it to both sides, okay? And it has to be an improper fraction for this to work. Now, this is now a perfect square. If you multiply this times this, you will get that. That's the way it works. Okay, that's why this process is called completing the square, perfect square. All right, add those together. Make sure, watch your signs. Please, 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 watch your signs. You will not end up with a negative number over here. You cannot, because you can't have a negative under a radical. Anyway, so square at both sides. That just drops the square over here. Plus or minus, radical on the top, take the square root of the bottom here. Then just add, since this is minus, we're going to add it to the other side. Okay? Since the denominators are the same, we can just put the numerators together over the common denominator. Or you can do that. It doesn't matter. It's completing the squares. So look on the page. Look on the page. Look on the top of page 499, example 118.3, to see the steps. Okay, I would highly suggest, as you go back and listen to this video again before you try this, write it down. Do what I'm saying to do. Do it with me. Get some muscle memory in here. It's not a complicated process, but you have to get the steps. You have to watch the signs.